Figure 1 shows a sketch of part of the curve C with the equation y equals x cos x. The finite region R, shown shaded in Figure 1, is bounded by the curve C and the x-axis for x between 3 pi over 2 and 5 pi over 2. Part A. Complete the table below with the exact value for y corresponding to x is equal to 7 pi over 4 and with the exact value of y corresponding to x equals 9 pi over 4. So if we substitute 7 pi over 4 into our function here and here, so if I do y equals 7 pi over 4 times cos 7 pi over 4, I get the answer 7 pi root 2 over 8. If I now do the same thing for 9 pi over 4, so again substitute the 9 pi over 4 in here and here. So 9 pi over 4 times cos 9 pi over 4, I get 9 pi root 2 over 8. Part B. Use the trapezium rule with all 5 values in the table to find an approximate value for the area of R, giving your answer to 4 decimal places. So, trapezium rule is half times the height of the first value plus the last value plus 2 lots of everything in between. In this case, the height, so what's it going up in each time? So to work this out, you could just do 7 pi over 4, take away 3 pi over 2. And we get pi over 4. So it's going up in pi over 4s, so the width of each trapezium is pi over 4. Then we have the first value, which is 0, plus the last value, which is 0, plus 2 lots of everything in between. And if we work that out to 4 significant figures, we get 11.91. Part C. Finds the integral of x cos x with respect to x. So we need to do some integration here. And we're going to integrate this, and we're going to use by parts to do it. The reason why we're doing by parts is because we've got the product of 2 functions. We've got the x times the cos x. So I'm going to let u be equal to x, and I'm going to let v dash be equal to cos x. Differentiating the x, I get 1. Integrating the v dash, cos integrates to be sine. Now applying the integration by parts formula, which is uv minus the integral of u dash times v. So I would get x times sine x minus the integral of 1 times sine x (1 times sine x is just sine x, and that's going to integrate easily. So the sine x is going to integrate to be minus cos x, and the minus minus is going to make a plus. Not forgetting the constant of integration. So this is my answer for part C. And then finally for part D, we need to find the exact area of the region R. So the region R was can be calculated by doing the integral of the x cos x between the limits of 3 pi over 2 and 5 pi over 2. So all I need to do is substitute those limits into the integration I've already done in part C. So my upper limit is 5 pi over 2, my lower limit is 3 pi over 2. And substituting those in, so I'll get 5 pi over 2 times sine 5 pi over 2 plus cos 5 pi over 2 minus 3 pi over 2 sine 3 pi over 2 plus cos 3 pi over 2. And that gives me, as my answer, 4 pi. And we're done.